Okay, this is assignment number 11 notes. It's on piecewise functions. I'd like to start off by just talking about what a piecewise function is. It's really just, like let's just say you have two lines on a graph. Okay, a piecewise function would be a piece of one of the lines and a piece of the other line. Okay, we just want a piece of each, so we're not going to graph the whole thing. Okay, and that is denoted by a restriction. So if you're looking at this example right here, remember f of x just means y equals. Okay, we have this line 2x plus 3, but we only want to graph that line when x is less than 0. Okay, and then we have the line 4 minus x, and we only want to graph that line when x is greater than or equal to 0. Excuse me. First, we're going to talk about evaluating. Remember, this is just an x value, okay, the number in that parentheses right there. So we're going to plug this into x, but into the correct one. You don't plug it into both. You don't just pick the top one. You've got to decide based on these restrictions over here, okay? So 3 is greater than or equal to 0, so we're going to plug 3 into this bottom one, not the top one. And 4 minus 3 would be 1. 0. When x is 0, we're still in this bottom one, because 0 is greater than or equal to 0. So 4 minus 0 would be 4. And then this last one, negative 3 is less than 0, so we're plugging it into the top one, so it would be 2 times negative 3 plus 3, and that's going to give you negative 6 plus 3, which is negative 3. Okay, that's how you evaluate. You just got to pick the right one based on your restriction. These are your restrictions on the far right, and then substitute that value in for x. Okay, here's how we graph. Okay, we're going to make two different tables, okay, for our graph, one for the first equation, one for the second equation. We always want to start with this number right here. So I'm going to start with 0, and I'm going to plug 0 into this equation. 2 times 0 plus 3 would give me 3. Okay, before I go plot that point, I have to decide, is that getting an open circle or a closed circle? If this is an equal or not an equal sign, it's an open circle, and if it's an equal sign, it's a closed dot, circle, whatever you want to call it. Okay, since this does not have an equal sign, at this point we're going to be open. So we go to 0, 3, and we're open. Just a big open circle. Okay, then you don't want to make it too big, you don't want to make it too small, just so you can tell it's open. Okay, now we're going to pick, we know it's a line, we need at least 2 points to make a line, okay, but we want to pick numbers less than 0, so we'll just pick negative 1. So when I plug negative 1 in for x, 2 times negative 1 would be negative 2, plus 3 would be 1. So I'd be at the point negative 1, 1. Just put a dot there so we can connect the things. And then if you want to just verify that, you could pick another number, negative 2. 2 times negative 2 is negative 4, plus 3 would be negative 1. So it'd be the point negative 2, negative 1. Okay, and then we're just going to draw our line. Now, normally, if I were to just graph the line y equals 2x plus 3, the line would keep going this way also. But all of these values, even though we're going up, are x's bigger than 0. Remember, on this side, x's are bigger than 0. So any point I graph over here is not in this restriction. Okay, then again, now we're going to go to the second equation. Again, we're going to start with 0 and plug 0 into the second equation. 4 minus 0 is 4. And we're going to go plot that point. I'm going to write this, by the way. This was open. Now, there's an equal sign on this equation, on that inequality symbol. So we're going to be closed at 0, 4. So we go plot the point 0, 4, and we're closed. See the difference between open and closed? And now 1 or 2 more points. Numbers bigger than 0. So we'll pick 1. 4 minus 1 is 3. So go plot the point 1, 3. And then we'll pick 2. And 4 minus 2 is 2. So we have the point 2, 2. Sorry, the lights in my room just went off. It looked like it changed a little bit. Connect your dots with your line. Make sure you put an arrow on the end. And that's what a piecewise function is. Okay, it's a piece of this line, and it's a piece of this line. Remember, lines keep going normally in both directions, but we only want pieces of them. All right, number 2. Okay, we're going to evaluate first. So we have two equations, 2 linear equations. The first one says we only want the numbers less than or equal to 3. The second one says we want only numbers greater than 3. We always start with 3 even though it just says greater. Okay? These 2 numbers are always going to be the same until we get to 3 different equations in here, and I'll show you that on the back side. So we'll start with evaluating f of 6. F of 6 is going to go into the bottom one. Well, the bottom one is a horizontal line, and this says y equals 4. No matter what x is, y always equals 4 when x is bigger than 3. So since 6 is bigger than 3, y is 4. Okay, B, x is 0, so I'm going to plug 0 into the top one. Okay, 2/3 times 0 is 0, and 1 minus 0 is 1. Okay, don't freak out because this says pi. You should know that pi is 3.14. 3.14 is bigger than 3, so it's the bottom one, and on the bottom one, y is always 4. Okay, and when we graph that, remember, when it's just a y equals, no x in here, that's a horizontal line. Okay, that's why it's constant, it never changes. Okay, we don't have to make a table. Okay, I'm going to show you how to do it without making a table. Again, we always start with this number 3. Okay, so we're going to plug a 3 into this equation. 2/3 times 3 is -2, and 1 minus 2 is -1. So when I plugged a 3 in, I got -1. And that is going to be a closed circle because of this equal sign. So at 3, -1, we are closed. Okay, now we're going to pick a number less than 3. Okay, I don't want to pick 2 or 1 because then that gives me a decimal or a fraction answer here. So I don't have to pick the very next number on a number line. I can pick any numbers I want that are less than 3. So I'm going to pick 0 this time. 0 is less than 3. 2/3 times 0 is 0, and 1 minus 0 is 1. So when I picked x as 0, I got y as 1. Okay? It only takes 2 points to make a line, so I'm going to go ahead and graph my line. Make sure you put an arrow on the left side of that line. And then this one is y equals 4 when x is greater than 3. Again, you're going to pick 3, and when you pick 3, y is 4. So I'm going to go to the point 3, 4, and it's going to be an open circle because I do not have an equal sign under my inequality. So open at 3, 4. And I'm going to pick numbers bigger than 3. So when I pick 4, y is always 4. So when x is 4, y is 4. When x is 5, y is 4. And we keep going. That's why it's a horizontal line. Y never changes. Okay, number 3. Number 3 now has 3 equations. We're going to go ahead and make 3 tables just so we could keep them separate. Okay, and we'll start with the first one. We'll start with the number 0. And when I pick 0, 1/2 times 0 is 0, and I'm closed. So it's, sorry, scratch that, erase that, pretend I never said that. I'm open. So it's 0, 0, I'm open. And then I'm going to pick a number less than 0. I don't want to pick 1 because I don't want to graph a decimal. So I'm going to pick -2. And half of -2 is -1. So when x is -2, y is -1. I have my 2 points, and I know it's a line. And I'm going to put my arrow on the end of that line. All right, now when we have three equations, it gets a little trickier because now we have numbers in the middle. So notice these two numbers match, and then these two numbers match. So these two graphs have a 0 in common, and these two graphs have this 2 in common. That's where they meet up or are apart from each other. Okay? So we're going to pick 0 in this graph, and we're going to plug 0 into x. 0 plus 1 is 1, and we're going to be closed because of that equal sign right there. And then we're going to pick 2. 2 plus 1 is 3, and again we're closed because of this equal sign. So at 0, 1, we're closed, and at 2, 3, we're closed. And we're going to connect them. But arrows do not go on the ends of either one of these because we're only going between 0 and 2. If I put an arrow, it means we keep going. All right, then the last one. We're going to start with 2. 3 minus 2 times 2 is negative 1. And we're going to be open because no equal sign. And then pick another number greater than 2. So let's pick 3. And when I pick 3, 2 times 3 is 6. 3 minus 6 would be negative 3. So plot these 2 points. 2, negative 1, open. 3, negative 3. Put a dot there. Connect your dots. And then an arrow goes on that end. Okay, so you should have an arrow on the left end. You should have an arrow on the right end. There should be no arrows in the middle. All right, the last one is evaluating. Now we have 4. We're not going to make you graph 4, but we will evaluate 4. You just got to pick the right one. You have 4 different restrictions over here. Less than negative 4, between negative 4 and negative 1, between negative 1 and positive 4, and bigger than positive 4. First one is negative 6. That's going into the top one. Okay, so it's the absolute value of negative 6 minus 3. Negative 6 minus 3 is negative 9, and the absolute value of negative 9 is positive 9. Next one is 0. 0 is between negative 1 and 4, so I'm using this third equation here. And no matter what x is between negative 1 and 4, y is always 3. Okay, I picked 2. Same equation. 2 is between negative 1 and 4, so the answer is 3. There's nothing to plug in on that one. D is 6. 6 is bigger than 4, so I'm on this bottom one, so it's 2 minus 6 squared. Type that into your calculator and you get negative 34. When you do put this in your calculator, make sure you put parentheses around that 6. Negative 1. Now, negative 1 is a number that's on 2 different equations. Okay? So when it's like that, you've got to find the one that it's equal to negative 1. That's this second one right here. Okay? So now you're going to put a negative 1 in for that x. It's negative 1 cubed plus 1. When you type this into your calculator, again, make sure you have parentheses around that. And that's going to be negative 1 plus 1 is 0. And then here's another one. The last one, example F, is 4. 4 is on both of these equations. But the one that's equal is the third one. And the answer on the third one is always 3. Okay, hope that helps you. Hope you guys are getting along. And if you need any help, please send me a message.